Hello, I'm Emily Borgo-Canale.
And I'm Sasha Reydman, and today we're going to present to you the Van de Graaf generator. It was first built in 1931 by a man named Robert Van de Graaf.
And the initial goal of this generator was to be used as a particle accelerator, which led to many advancements in nuclear physics and other research.
Yeah, it functions on the principles of electrostatic interactions and static electricity, and it's basically able to generate extremely high electric potentials and extremely high voltage by accumulating electric charge on a hollow metal sphere that rests on top of an insulated column by moving electrons up through an insulated belt that rotates and brings electrons up from the ground and transfers and concentrates them on the hollow metal sphere. So we present to you the Van de Graaf generator. The generator is made up of two rollers found at the top and bottom of the contraption, and they're connected together by an insulating belt, which is typically made of a material like rubber.
Additionally, there are two brush-like metal forks near but not touching the top and bottom of the belt. The bottom roller, which is grounded, accumulates a negative charge and generates a strong electric field in its surrounding area. The negative roller repels electrons from the metal brush's points, giving it a positive charge. This allows the belts to take on a positive charge.
The battery, which is attached to this contraption, works as a power source to mechanically rotate the positively charged belt around the rollers, and so the positive charge is brought up from the bottom roller to the top roller. And due to the positive charge on the belt, once it reaches the top, electrons are pulled from the top metal brush onto the belt surface in an attempt to neutralize it.
These electrons come from the hollow sphere's outer surface, which is in electrical contact with the brush. Similar to a Faraday cage, any charge that's deposited on the interior of the sphere ends up on the outside while the inside remains neutral. This is what allows the generator to build up such a high voltage. Because the inside is always neutral, you are able to continue depositing more and more charge to the outside of the sphere.
And as you can see indicated by the arrows on the diagram, the generator works in a cycle of bringing up positive charges from the bottom, depositing them onto the metal sphere at the top, and coming back down again as neutral to the bottom, where it can continuously accumulate and deposit more and more positive charge.
Aside from its contribution to research, the generator has several industrial applications such as food sterilization. This is accomplished by particle acceleration.
During the pandemic, it was also found that the Van de Graaf generator could similarly sterilize N95 masks for nurses, which was a significant discovery during this time, allowing there to be greater and more consistent supply of personal protective equipment in the medical setting.
Fun fact, it can also be used as a fun science trick to make your hair stand up. Additionally, if you increase the radius of the metal sphere at the top, you can actually increase the electric potential, which is given by the equation V is equal to RE. So that's why if you increase the diameter, then you can have greater voltage.
I would not recommend doing that. Thanks for listening to our mini projects.